So let's start with great circle sailing. Great circle is sailing. In great circle sailing, we need to know the shortest distance between any 2 points. Suppose we are going from point A to point B on the earth. We need to know the distance along this straight line, or this, which is the shortest distance. So so if it is on a plane surface, then shortest distance is the straight line. But the earth is a spherical place, spheroid. So if this is on the earth, it cannot be a straight line. So what will be the shortest distance? So if we consider that these 2 points are on a sphere or a circle or a ball, so if this is point A and this is point B, then these 2 points are on the sphere. So what is the distance or the shortest distance between A to B? So it will be the arc of the circle passing through the 2 points and having the greatest possible radius. So this circle is having the greatest possible radius, which is, and this is the center, and the center of this circle is the center of this big circle. So we can say if the radius reduces or it is less, the distance along the arc will increase. So largest radius, minimum shortest distance. That is the rule. So in case of Earth, Earth is spherical, just oblate spheroid, but we consider spherical for mnemonic charts and great circle sailing. Straight line track for large distances is not possible. So great circle sailing is used for very large distances. So what we have is the shortest distance between any 2 points on the surface of the Earth. Shorter arc of the circle passing through the 2 points and having the largest radius. So as we saw, the largest radius will be which is a great circle, which is passing through the center of the circle. So like this example, you can see this is point A and B. The shortest distance between any 2 points on the Earth's surface is found out by the shortest distance is passing through the 2 points. That is a shorter arc of the circle. So this is a great circle. Great circle is that the center of great circle is passes through the center of the Earth, or center of the sphere here. So center of the Earth and the center of the great circle is same. Hence the radius of great circle is also the radius of the sphere, which is maximum. So maximum radius is also of the great circle only, which has the same radius as the Earth. And this is a small circle, and small circle will have a radius always lesser than the great circle, which is passing through the center of the Earth. Hence, shortest possible distance is the great circle distance on the Earth. And rhumb line distance or a straight line distance is always more if we take for large distances. So great circles is always the shortest distance. We'll have a lot of saving of distance in large courses if we are going from suppose Europe to North America, like that, across oceans. So in east-west distance, we have the maximum saving, and in north-south direction, we get minimum saving because you are traveling along the path of the meridian. And if you're sailing along the equator, then you will have maximum difference in great circle sailing is nil because rhumb line and your this thing straight line course and great circle course is same. Now, if you are sailing in a mid latitudes or high latitudes in the east-west direction, so suppose we have east and west, and we are sailing in high latitudes, so you will have maximum saving in this case. That's what we said. If you're going from Europe to North America like that, generally we do, or from Japan to America. But great circle requires a continuous change of course at every point. So as you can see, you need to change the course at every point. So we divide it into different parts, difficult, and we cannot change every minute or every second. And so we divide this great circle into short lump line approximate GC track. So we divide them, suppose say every 10 degrees of longitudes. So this series of longitudes we join, and then we steer a course for some time, and then we change the course. So like this, we do great circle sailing by dividing it to a series of rumb line tracks. Because Mercator's chart, we can only plot rumb line only. So let's say this example, we have a point, we are going from point A to B, and we are on equator, and we are going from point A to B. So great circle is always curved towards the pole. So great circle is always curved towards the pole. But if you are making a great circle in different hemisphere, if A is in southern hemisphere and B is in northern hemisphere, then your great circle will be have different curve. So above the equator, it will be curved towards the North Pole, and below the equator, it will curve towards the South Pole. Towards the South Pole from A to the equator. So this is how you'll make diagrams and then measure the angles. So same example for measuring the angles. A is in southern hemisphere, B is in northern hemisphere. So initial course is the angle A and final course is angle B. So from A to equator, the curve is pointing towards the south pole, and from equator to B, the curve is pointing towards the north pole. Now to find, we have to find the courses in the questions. So latitude A, if you say that latitude A is equals to latitude B, but they will have different name, 20 degrees south and 20 degrees north. So if the latitude is same, then initial and final course you will get the same. So let's see one more example. We have position point A 20 degree north, 70 degree west, and point B is 40 degree north, 50 degree west. So we will plot in the for the example. So we have North Pole, South Pole, equator, east, west. So we need to find the great circle distance between these two positions and initial and final course. So we need to have a formula, which is a cosine formula, which is used for finding the great circle distances and course. So we put this position A 2070 and B 4050. So cos PA and cos PB, cos AB side is will be equal to cos PA side, cos PB side, and sin PA side, sin PB side into cos P. So cos P is a angle at the pole. That is the difference between the longitudes. So PA is 70 because A to equator is 20 degrees. Then B to equator is 40. So PB is 50 degrees because equator to pole is 90 degrees. So cos PA is 70 and cos PB is 50. Then sin 70, sin 50, and cos P. cos P is the angle between the longitudes. So between 70° west and 50° west is 20 degrees. So from more west, we are going to less west, that is 20 degrees east. So this is the D long, 20 degrees. So from 70° west, we are going to 50° west, that is we are going 20 degrees east. So we are going to easterly direction. So after putting in all the values, we get the distance AB, that is 26.3266. So from the scientific calculator, we get these values. So it's advisable to use the maximum digits, and then we multiply by 60. So this is 26.32 degrees. We get 1579.6, and now we can round off. It is the great circle distance, 1579.6 miles, or 1580 approximate miles, you can say. Now we want to find the initial course, so we can use this formula again. So we have cos of angle A is equals, for finding the initial course, we have cos PB is equals to cos PA cos AB. So cos PB is this side and cos PA is this side, and cos AB is this side. So we have a separate video for cosine formula. So this is, we take out cos A from the formula and we punching all the values. We have already taken out what is PA and AB. So AB we have just calculated. You can put in degrees. So you get angle A is equals to 36.2122 degrees. Or if you put in degrees, 36 degree, 12 minutes, 43.99 seconds. And you can round off 36 degree, 12.7 minutes. So 036, 12.7 minutes is your initial course. So you can put 037 degrees true approximate by putting in closest degrees. Or you can say name it as north 36 036 12.7 east, or 037 north 3037 east, or 037 degrees true. Now how to calculate angle B? Again we have a cosine formula. So again, cosine of angle B and opposite side cos PA, opposite side, and then cos of PB of side upon sine of AB. So different sides we compare, and that is our, so same way cos B formula, we can, I will tell you the detail of the cosine formula later on. So cos B we put in the cosine formula and we get all the values, and we get the angle B 133.55 degrees, that is 133 degrees 33 minutes 23 seconds. Now again you can see that we found out the angle which is on this side, but the vessel, we need to give the angle from the north, the course to steer. So we have to be very careful which angle which we found. So from this formula we found this angle B, but we need to give the course which is measured from the north. So we found, so we have to give the angle from the course. So if you subtract 180 from this angle, you will get this angle 46, 26.60. So you can put 046, 26.6.